Hey everyone, and welcome. If you're working with data at any serious scale, you've definitely heard about the data lakehouse. But what you might not know is that underneath it all, there's this huge battle going on, a tech showdown that's going to define how we all manage data for years. And today, we are diving right into the middle of it, the format wars, Delta Lake versus Apache Iceberg.
So let me start with a question, and be honest. Does this look a little too familiar? You built a data lake, you were promised all this flexibility, but now it's just a mess. A data swamp where finding anything you can actually trust is, well, basically impossible. It's a super common problem, and it's what kicks off our whole story.
So, how do you fix the data swamp? You bring in something called an open table format. Now just think of this as a brilliant little layer of metadata that sits on top of all your messy data files. It's what brings all that good stuff from traditional databases like ACID transactions, which make sure your data operations actually complete correctly, right into the wild world of the data lake. Plus, you get amazing features like time travel to see what your data looked like yesterday, and schema evolution so your tables can change over time without everything breaking.
Right. So to really get why these new formats are such a game changer, we have to first understand the pain. We have to go back to the original promise of the data lake and where it all went wrong.
You see, the original big idea was this thing called schema on read. It sounded great. Just dump all your data in one place, any format, and we'll figure out what it means later. But in reality, it was a recipe for chaos. You'd get inconsistent data, queries that would just fail for no reason, and pretty soon, nobody trusted the data anymore. And that is the data swap.
And that chaos is exactly what led to our two main contenders, our two titans. On one side, you've got Delta Lake, which came out of Databricks, and on the other, you have Apache Iceberg, which started over at Netflix. Now, they both solve that same core problem of bringing reliability to the lake, but, and this is the key, they do it in two totally different ways.
And this slide really gets to the heart of that difference. Delta Lake's approach is all about a transaction log. It's dead simple. You can think of it like a diary for your data table. Every single change that ever happens gets written down, one after the other. Iceberg, on the other hand, uses a hierarchical metadata tree. This is more like a super efficient library card catalog, with snapshots and manifests that point to the exact data files you need. It's built for massive, massive scale.
So how does that design choice play out in the real world? Well, let's look at this chart. As you can see, both of them nail the basics, like ACID transactions and time travel. But the differences are where it gets really interesting. Look at schema evolution. Iceberg is just fantastic here because it tracks columns using unique IDs, not just names. That means you can drop a column, add a new one with the same name later, and it won't get confused. And even bigger is partition evolution. With Iceberg, you can change how your table is partitioned without rewriting all the data. That is a massive operational win. And finally, look at the ecosystem. Iceberg was born to be engine-agnostic, to work with anything. Delta, well, its roots are very, very deep with Apache Spark.
But here's the thing. It doesn't matter which format you pick. There is a common enemy, a silent performance killer that you are absolutely going to face. And it's called the small file problem.
So what is this thing? Well, it usually happens when you've got a lot of frequent updates, especially from streaming data. Every little insert can create a brand new tiny data file. Do that for a while, and you can end up with literally tens of thousands of little files for a single table. And that just crushes your query performance.
And the reason it's so bad is actually pretty simple. This quote here really nails it. Every single file, no matter how small, has a fixed cost just to open it up and read it. So when your query has to do that thousands of times just to get a few rows of data, your whole system just grinds to a halt.
Thankfully, there's a solution, and both formats have it. It's called compaction. You run a command like optimize or rewrite data files, and the system goes to work. First, it identifies all those tiny files. Then it reads them all and rewrites them into a much smaller number of big, chunky, optimized files. And finally, it commits that change in one single safe atomic transaction, so you don't have to worry about messing up any queries that are running at the same time.
So what's the goal here? What's the perfect file size? Well, the general sweet spot for performance in a data lakehouse is somewhere between 100 megabytes and 1 gigabyte. That's the perfect balance between the overhead of opening files and the ability to process them in parallel. Okay, so we've solved the data swamp. We've tackled the small file problem. We're done, right? Not quite, because solving one problem has created a new one. In today's world, it's not enough for your data to just be reliable. It has to be readable by a whole universe of different tools. I mean, just look at this list. This is the reality for almost every data team now. You might be using Spark for your big ETL jobs, Trino for fast SQL queries, Flank for real-time streaming, and then connecting it all to data warehouses like Snowflake or BigQuery. The really big question is, how do you get one table format that can be read and understood by all of them? And this is where that design philosophy we talked about, especially Iceberg's focus on multi-engine support, really comes into play.
And this brings us to the big strategic decision, especially for any teams out there who might have started on a Spark-centric format like Delta, but now need to support all these other engines. The choice really boils down to two paths. Do you unify or do you migrate? So the unification path is all about a feature called Delta Lake Uniform, and it's pretty clever. Think of it as a translator. You turn it on, and your Delta table starts generating not just its own metadata, but also Iceberg metadata. This means that tools that only speak Iceberg, like Trino or BigQuery, can now read your Delta table directly, without you having to copy any data. Your one table is now effectively bilingual.
The other path is a full migration. This is where you decide to convert all your Delta tables into native Apache Iceberg tables. Now yeah, it's definitely more work up front, but the payoff is that you are fully embracing an open, vendor-neutral standard. The goal is to get the absolute best performance and the best feature support across that entire multi-engine world we just saw.
And that leaves us with one last question. And this one is for you to think about. When you look at your own data platform, at your own team's needs, what does the future look like? Is it a unified one, where you build clever bridges between systems? Or is it a migrated one, where you make a strategic bet on a new, more open standard? The path you choose is going to shape your data strategy for a long, long time.